Hello everyone, I'm Natan from Robusta.dev. I was a developer for many years. Like all of us, I'm tired of being woken up at night by alerts. And today I'll be speaking about alerting on Kubernetes and some of the challenges that come with that and some of the challenges of alerting at scale. Now, to get started, I want to just clarify, I'm not speaking about how you define your alerts. I'm going to assume that you have Prometheus, you have Alert Manager, you have another alerting system. And I'm talking about everything on top of that, how you respond to those alerts, how you investigate them, how you remediate them, and how you can automate that with software. And we're going to be looking at this from a Kubernetes specific perspective. So we'll be looking at some of the challenges that Kubernetes brings and some of the advantages as well. So let's start off by looking at the challenges. So challenge number one is high velocity. And in general, we think of high velocity as being a good thing. The faster you go, the better, and you can get software up and running really fast. And whoops, I just added on 0 to the end of the line. And now instead of 10 pods, I have 100 pods. And on another 0, you have 1,000 pods. So high velocity is a really good thing, but it means, one, you end up running software in production earlier and faster than ever before. So you end up with a lot more stuff in production a lot faster. And two, when stuff goes wrong and there are incidents, then it's often better if stuff goes wrong when you're moving at low velocity. And of course, a car crash is a good example of that. If you're going very slowly, then there's less damage. Now, challenge number two that's unique to Kubernetes is that the default alerts are often very noisy. Now, this isn't a fundamental issue. Like, there's kind of no excuse for this, but it just is something that really needs to be worked on by the community today. And we're also trying to do some work on improving this and improving the set of standard alerts for Kubernetes. And the challenge here is that if you install an alerting system on your cluster and you install it on an empty cluster that's completely healthy, then you don't want to get any alerts. And you don't want there to be any noise. And you want, when things are all working and everything is quiet, then you just want an empty Slack channel. And sometimes that's unfortunately not the case today. And there's been a lot of great work done by the community to try and create a good set of baseline alerts. And we're also doing some work ourselves there to try and chime in with that. Now, challenge number three is what I like to call auto-scaling alerts. And of course, we all auto-scale our pods and we auto-scale our cluster. And we recently did a survey with a bunch of DevOps and SREs and developers running on Kubernetes. And we asked them about their alerting. And we asked them how they felt about the alerts that they got in Slack or in other destinations. And I put here just two specific quotes that I thought really illustrated the type of feedback we got. And one person said, lots of pods equals lots of alerts. And the other person said, it's hard to distinguish between the high alerts when there are 100 plus mails. And the general point here is that if you're auto-scaling your pods, then you're also going to auto-scale your alerts. Now, in theory, you just have grouping, and grouping deals with that. But in practice, that's not always the case. So let's say you're grouping alerts by service, or you're grouping it by alert name, and you have an alert that fires once in every 100 hours of runtime. And you have one instance of that running, then that alert will fire once in every 100 hours. But if you now have 100 copies of that pod running, it's going to fire a whole lot more frequently than once in every 100 hours, assuming it distributes equally. And of course, when you have a whole bunch of applications, and each application has its own little quirks and its own issues that occur now and then, and you have a whole lot of applications running on Kubernetes, and you've auto-scaled, and you're moving really fast, and you're getting all these applications on Kubernetes, and you're delivering all these apps really fast, then you're going to auto-scale your alerts, and that's a bad thing. So we did a survey recently, like I mentioned, and I just put in here two specific numbers from that survey. So first, we asked people, how important are errors and crashes in your environment? How much do you care about each individual alert and crash, and how much does it mean something? And 48% of the people said it's really important. And I think the other 52% here is basically saying, like, okay, well, Kubernetes is self-healing, so like stuff can crash a little bit, and that's fine. And there are two sides of this, right? But then we ask people also, okay, well, how do you feel about the alerts that arrive? Do those alerts actually mean something? And there only 21% of people said that the alert means something. And everyone else said, I get alerts and they don't always mean something. Those alerts aren't real. So whether every single crash means something, whether every single error means something or not, it's kind of about how you approach it and whether you want to just let the cluster self-healing stuff do its own thing or not. So that's up to you. That there are different approaches there. But when you get an alert, then you want every alert that you see to actually mean something, so you know what to focus on and whether you should look at that or not. So that's a big challenge that people face. Now, I'd like to speak about the other side, the benefits of running on Kubernetes. and the benefits specifically of Kubernetes for the world of alerting. So benefit number one is there's this massive standardization. When I first set up the server, I got started, I think in high school, I was running a WordPress server. And when I set up that WordPress server, I went to Google, I Googled Ubuntu, set up a Linux server, and I found a tutorial on ubuntututorials.com on how to set up a LAMP server, Linux, Apache, MySQL, PHP. And I set that up, and if I went to someone else on a different machine, or if I looked at Google's data center, if I looked at another website like Facebook, which ran on PHP, and I looked at their server, then their LAMP stack was very, very different than my LAMP stack. We were both running the same software. We all had Linux, we all had Apache, we all had MySQL, we all had PHP, but they were all very different than one another. They were packaged differently, they were installed differently, and the environments looked very different. On the other hand, today, there's been this massive standardization due to containerization, due to Kubernetes. And we all deploy containers that are very similar to one another. Often we're even deploying the same exact containers, using the same exact Helm charts. And there's all this infrastructure and all this structure in terms of how we work. And when we deploy software, then the software deployed by me often looks very similar to the software running by you. Now, we have very different business needs. We do different things. We're in different companies. But still, when there's an issue in the MySQL running on my Kubernetes, that can look very similar to an issue in the MySQL running on your Kubernetes. So there's huge potential here for sharing operational knowledge. And of course, part of that is the operator pattern. And part of that is the operators and control loops built into Kubernetes, but also in general for how you handle alerts and issues. Then there's this potential to really collaborate and share that knowledge. And number two benefit that we have with Kubernetes is that there's a rich control plane. So we can observe changes and errors better than ever before. And because Kubernetes has all this metadata in the API server, then I can ask questions like, okay, what happened 5 minutes before this alert fired? Or on the same node where this alert fired, what else was happening at the same time? Or I can say, okay, if this alert fires, now go and fetch me this other data, bring in the logs from this other place. And I can do all this rich troubleshooting via Kubernetes API and via the control plane that I wouldn't have been able to do in the past. So let's say in the past, if I go back, maybe I'll take a different example. Let's say I have a Kafka running, and now Kafka starts throwing away messages because messages are either too big, that are over the max size. Now, I want to go and troubleshoot that, and I want to do different things, but in the old world, my monitoring system probably didn't even have the credentials to connect to Kafka. But under Kubernetes, now we have this control plane, and I can gather data, and I can very easily, even automatically, do kubectl exec and gather data from the exact place where that error is occurring and see why it's occurring and fetch logs and do all these other operations. So due to this control plane, we can build much richer and better solutions for alerting. Now, the third benefit that Kubernetes brings is in general, there's really, really good tooling for everything. And deployment is a solved problem. And it's really easy to get your software up and running. We do it in standard ways. And now we can focus, instead of building in-house tooling just around deploying software and rolling out changes or doing canary deployments and stuff that in the past we would have developed maybe in-house, we can take standard solutions for those. We can also start to take standard solutions for alerting and to build them together. And we can really focus not just on getting software up and running, but because that's a solved problem, because we're moving so fast, because we're moving at high velocity, we're getting the software up and running really fast, we're rolling out changes really fast. Now we can also focus on the part that comes afterwards, which still isn't a solved problem. That's how we handle the alerts and how we monitor and how we automate the processes there as well. And DevOps is all about automation. We've done a really good job on automating the deployment side. Now it's time to really start focusing on automating the maintenance and alerting and monitoring side as well. So the question is, how do we take this, which is what sometimes alerts look like on Kubernetes, and we turn it into this? And I want to compare this here also again to deployments. It used to be that each company had their own ad hoc solutions for how you would get software into production. And today, there's all this structure. So you have a Docker file, you have standard Kubernetes manifests, YAML files, you have a Helm chart. Everything is very structured, sits in the Git repository, you know exactly what's going to happen. No one is running these ad hoc commands that maybe they forgot to document in the wiki to set up their servers, or at least not set up applications. To set up applications, you just run kubectl apply and you're done. You have this structure and everything is documented, and you have infrastructure as code, and everything is fantastic. So how can we apply that same structure to the way that we deal with alerts? So I'd like to look at 3 principles of Kubernetes, and then I'll show how we can use these principles for alerting as well. First of all, declarative. We want to express what we want to happen in declarative YAML files. 2, GitOps. We want to take that YAML file, we want to stick it in Git. Now we can track it and we can see what's going on. So we don't set up servers ad hoc anymore. Everything is just inside that YAML file that sits in the Git repository. We track everything, infrastructure as code, and life is fantastic. And part 3, automation, we let the machine do it for us. And we essentially say to Kubernetes, okay, I want 5 pods, and if one goes down, it brings it back up. And Kubernetes handles 5 aspects here using automation and self-healing systems. And we want to apply some of those same principles to how we handle alerts as well. So I'm going to compare here the old way of handling alerts versus what I call the Kubernetes way. So the old way would be to handle alerts ad hoc. The Kubernetes way is to handle alerts automatically. And handling alerts could just mean investigating them automatically, or telling you why they occur automatically, or pulling in context. It's not necessarily fixing the alert, which can't always be done automatically, but I'll speak more about that in the next slide. The old way was to keep knowledge in your head or in a wiki, and the new way is infrastructure as code. So your knowledge, it becomes a YAML file that sits in Git. The old way was to remediate issues manually. The new way is automatic remediation, or semi-automatic remediation, or asking Kubernetes to do something and then handle the details. Now, the old way was to develop in-house solutions, just like we did for deploying software. The new way, cloud-native solutions. We use a standard solution. The knowledge and the infrastructure and all the tooling around that is standard tooling, standard software, and we just put inside those files or inside configuration exactly what we want to do and stuff that's unique to our environment. So here's the high-level approach that I recommend for handling alerts on Kubernetes. 1, defining YAML how to handle your alerts. And there are 2 types of actions that we see there. First are enrichment actions. So for example, you have high CPU, go fetch a graph of CPU. That's enrichment. A pod crashed, go fetch that pod's logs. You had an killer, pod was killed by the Linux out of memory killer. Go tell me what container got killed. Pull in a graph of the container, of the container's memory usage. I had a node. On that node, it ran out of space on the disk. Let's go and let's fetch a list of the files on the disk. Check which pod there, which was running on that node, used up all the space. So when I get an alert, I want to see in that alert that arrives in my Slack channel all the relevant data. Prometheus is an excellent way to trigger those alerts, but there's a step in between Prometheus triggering that alert and that alert arriving at you, where you want to enrich that and you want to add all this extra context, which then lets you respond really fast at 3 a.m. The second type of action that people do is remediation actions. So an alert fired, now in theory, everything in Kubernetes is self-healing, but sometimes there's different self-healing stuff that you want to do, which you can't just do based on liveness probes or health probes or that sort of thing. There's global stuff where an alert fires in one place and you need to kill a pod in another place because there's some issue. So we see a lot of very specific ad hoc stuff like that with our users. And for those cases, then you often want to do remediations. Now, remediations have 2 types. Remediations that are 100% automatic. So if something happens, you go in like Kubernetes itself, you self-heal, and you automatically apply a fix. Sometimes also this ties into the operator pattern and really kind of getting software to be the operator for you. And then the other thing here is sometimes you don't really trust the software yet to go and do something, and you want the software to just ask you. But you wake up at 3 a.m., you got an alert, says there in your Slack channel, here's the problem, here's the solution, just click this button to apply the workaround. You click it, you go back to sleep. So that's why I refer to as remediation. So the step 1, defining YAML, how you want to handle each alert. Could be enrichment, could be remediation. Step 2, notify the user. Tell the user something happened, notify them in Slack, notify them in Ops Genie, PagerDuty, different destinations. And if you need to ask the user what to do, how should I handle this alert, then ask them. But we're taking this entire workflow and it still is embedded in infrastructure as code like workflow in code that specifies how to handle each thing. Just like how we set up our deployments and how we deploy stuff and how we set up our software to begin with, that's how we should handle the alerts that come from it. And step 3, you want to do Kubernetes aware grouping and silencing. And when there's alerts, then you want to silence them maybe under certain conditions, or if you recently updated deployment, or if you're in the middle of a maintenance window. And when it comes to grouping, then you often want to group by microservice, or you want to take the same microservice across multiple clusters. And it's useful here to have software that really understands what Kubernetes is, and it understands concepts like deployments and like pods, and that pod is part of a deployment. And it's not just looking at it in terms of a label that has key equals value. So that can also be very useful. Now, I'll look at 3 different pieces of open source tooling that you can use for this. So the first one is Argo events and Argo workflows. Good piece of software, fairly complex, but very good software from the same people as Argo CD. And the core principle here is that essentially every step that you're going to take is running a container. So if something happens, in response, you run a container. So you get a very low-level primitive, which is essentially to run a container, but there are good triggering mechanisms for when you run that container, and so on. Tool number 2, StackStorm. StackStorm is probably the most mature of the tools here, the oldest tool. It's not Kubernetes specific. We're not particularly Kubernetes aware, but it's another solution that we see a lot of people look into. And then the third solution, which I myself work on, is Robusta.dev. And we're a little bit like Zapier or if this, then that for DevOps. And essentially you specify, okay, when this error occurs, when this deployment updates, when this Prometheus alert fires, then take this action and send it to me wherever. So those are the tools that we see used most commonly, and each of them has its own advantages and disadvantages. I won't go into that because obviously I'm biased. And thank you very much for listening. And if you have any questions, please reach out either by email or I'll be available today in Slack to answer your questions and let me know what you think and let me know if I missed any useful tools here. Thank you very much.